In this episode, we move from evaluating a model in theory to thinking about how it lives in the real world once you deploy it, because deployment choices can turn a mostly safe idea into a risky system very quickly. A secure deployment path is basically the route your AI feature takes from development to testing to production, including where it runs, what it can touch, and what happens when something goes wrong. Beginners often picture deployment as a single moment where you flip a switch and the model becomes available, but secure teams think in stages and guardrails. Those stages exist because you want time and space to catch issues before they reach real users and real data. When we talk about environments, isolation, and integration boundaries, we are really talking about containing risk so that mistakes have a small blast radius. The goal is not to be slow or bureaucratic, but to be deliberate enough that you can explain, at any point, what the system is allowed to do and what it is not allowed to do. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. An environment is a distinct place where software runs with a specific purpose, and the classic idea is development, testing, and production. Development is where you build and experiment, and you should assume it is messy because people try things, debug, and change settings rapidly. Testing is where you try to reproduce realistic behavior and measure whether the system meets requirements. Production is where real users and real business processes happen, which means the cost of mistakes is higher. For AI systems, these distinctions matter even more because the model's behavior can change with configuration, context length, and surrounding services like retrieval, memory, or tool access. If you let development experiments point at production data or production systems, you can accidentally leak information or trigger actions with no safety net. Secure deployment design means you keep those environments separated in meaningful ways, not just by naming conventions. That separation is part of what allows you to test responsibly, because you can break things on purpose in a safe place. Isolation is the practice of making sure one thing cannot unintentionally affect another thing, and it appears at multiple levels in AI deployments. There is isolation between environments, so a test run cannot accidentally use production credentials. There is isolation between users, so one user's data and prompts do not bleed into another user's experience. There is isolation between components, so a model service cannot directly reach databases or internal systems unless it is explicitly allowed. Isolation also includes limiting what the model can see in a single request, because the more context you feed it, the more it can leak or misuse. Think of isolation as building walls and locked doors, not because you expect everyone inside to be malicious, but because mistakes happen and curiosity is normal. When you design isolation well, a mistake becomes a contained incident rather than a full-blown breach. Integration boundaries are the lines where your AI system connects to other systems, like data stores, ticketing tools, document repositories, or identity services. Every boundary is a risk point because it creates a new path for data to flow and for actions to occur. If your model can retrieve documents, you must decide which documents it is allowed to retrieve and under what conditions. If your model can write to a system, you must decide whether that write is automatic or requires a human approval step. If your model can call external services, you must decide how to authenticate safely without exposing long-lived secrets. Boundaries are where you enforce least privilege, meaning you only grant the minimum access needed for the task. A simple beginner rule is that the model should not get God mode access just because it is convenient. Convenience is a short-term benefit, but broad access is long-term risk. A secure deployment path usually begins with a concept that is safe by default, meaning the initial version of the system has limited data access and limited ability to cause change. For example, an early deployment might only summarize text the user provides directly, without retrieving any internal documents. That keeps the system's data footprint small and makes its behavior easier to reason about. Once you have confidence, you can expand capabilities in controlled steps, such as adding retrieval from a curated knowledge base that contains only approved content. Later, you might add tool access, but only to tools that are read-only at first. Each step is a deliberate expansion of the attack surface, and each step should come with new controls and new evaluation. This staged approach is not just project management, it is security architecture in motion. When thinking about environments, one of the most practical security decisions is what data is used for testing. If you test with real customer data or real employee data, you increase privacy risk, and you also increase the chance that sensitive information will end up in logs or traces. A safer approach is to use synthetic data or sanitized data that matches the shape of real data without containing real secrets. For example, you can create realistic-looking support tickets that include fake names and fake account numbers. You can also use redaction to remove sensitive fields before sending text to the model. The important point is that testing should be realistic enough to expose failure modes, but not so real that it creates new exposure. Secure teams treat test data as part of the system's security posture because it determines what you might accidentally leak during debugging. Isolation also shows up in how you manage credentials and secrets for the model service. If your model is hosted, you might have an API key that allows your application to call it. If your model runs internally, you might have service credentials that allow it to access storage or logs. In either case, those credentials should be scoped and separated by environment. Development credentials should not work in production, and production credentials should not be used for ad hoc experiments. A common beginner mistake is to store a single powerful credential in a place where many people can access it, which makes incidents difficult to investigate and contain. A safer pattern is to rotate credentials, limit their privileges, and ensure that a compromise in one environment does not automatically compromise all environments. Even if you are not the one implementing it, understanding this principle helps you evaluate whether a deployment design is mature. Integration boundaries become especially important when the model is used inside workflows that involve decisions, approvals, or access. For instance, if a model drafts a response to a customer, that output should typically be reviewed before it is sent, at least until the system has proven reliable. If a model helps classify incidents, it should not be the final authority on severity without validation, because misclassification can lead to the wrong response. This is where you separate suggestion from action. A secure deployment path often starts with the model as an assistant that makes recommendations and only later, if ever, allows automatic actions. The boundary between recommendation and action is one of the most important boundaries in AI security because it changes what a bad output can do in the real world. Another aspect of secure deployment is how you handle updates and changes, because models and surrounding systems evolve. If you deploy a new model version or change the retrieval source, you are effectively changing the system's behavior, sometimes in surprising ways. A secure deployment path includes a way to test changes in a non-production environment, measure key behaviors, and then roll out gradually. Gradual rollout reduces risk because you can monitor for problems before everyone is affected. It also gives you an escape hatch if you detect unsafe behavior, like a sudden increase in policy violations or unexpected refusals. The main beginner idea is that change control matters for AI systems just like it matters for traditional software. But it is even more important because behavior can shift in ways that are hard to predict from code alone. You also need to consider logging and observability as part of deployment design because you cannot secure what you cannot see. Observability means you can answer questions like what prompts were submitted, what outputs were returned, which model version was used, and what data sources were accessed. At the same time, logs can become a privacy risk if they store sensitive prompts or outputs without protection. Secure deployment paths balance these needs by minimizing sensitive data in logs, applying access controls to logging systems, and setting retention policies so data does not live forever. For beginners, it is enough to understand that logging is double-edged. It helps you investigate abuse and failures, but it can also become a new place where secrets accumulate. Good design treats logs as sensitive assets, not as harmless leftovers. Isolation is also about performance and resilience, not just about confidentiality. If your AI feature shares resources with other critical services, a spike in usage or an abuse attempt can degrade the entire system. For example, an attacker might try to generate extremely long requests to consume compute or drive up cost. If the model service is tightly coupled to the main application, that surge can cause timeouts and outages. A A secure deployment path uses isolation to limit these effects, such as separating the model service from core transaction systems and enforcing resource limits. This does not require you to memorize infrastructure details, but it does require you to think in terms of containment. You want failure to be graceful, meaning the AI feature can degrade without breaking everything else. As you design integration boundaries, a helpful mental model is to think of the AI system as untrusted until proven otherwise, even if it was built by your team. That sounds harsh, but it leads to safer choices. If you treat the model's output as untrusted, you validate it before it reaches sensitive destinations, like databases, logs, or user interfaces. If you treat the model's requests for data as untrusted, you enforce access checks outside the model, using systems that already implement authentication and authorization. This approach prevents the model from becoming the gatekeeper for security decisions, which is important because models are not reliable at enforcing complex policy. Your deployment design should ensure that the model never becomes the single point of failure for access control. Instead, it should be a component that operates inside boundaries enforced by traditional security mechanisms. By the time you reach production, a secure deployment path should feel like a well-lit hallway with doors that lock, rather than a wide-open room with everything plugged into everything else. You should be able to state which environment the system is in, what data it can access, what actions it can trigger, and what controls exist at each boundary. You should also be able to explain how you would respond to problems, such as rolling back a change, disabling a feature, or tightening access. Secure deployment is not a one-time achievement. It is a way of operating that assumes systems will be tested by real-world behavior. When you design with environments, isolation, and boundaries in mind, you make abuse harder, mistakes smaller, and recovery faster. That is the real payoff, not perfect safety, but controllable risk that you can manage confidently over time.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.